In one of the previous videos, we're able to familiarize or derive the rule for the Laplace transform of quadratic function. Now this time, let's talk about the cubic function. Our function here is t cubed, and we might have some examples later on that would actually use this. So let's try to derive its rule or its transformation into a Laplace form, of course, using this perspective here. Now take note, when we try to come up with the Laplace transform of t squared, we actually use their integration by parts. Similarly here, we're also going to use that here, and most importantly, we might be using that multiple times. I'm talking about this one here. So I have the Laplace transform of your function t cubed is equivalent to the integral from 0 to infinity of your e to the power of negative st in our function t cubed dt. As you can see here, treating s of course as any other variable because we are only going to take the integral in terms of our t. This time, our form is actually not very basic. Hence, we're going to use here the integration by parts. So the first one here, of course, by the rule L-I-T-E-E, the Liate, on which would be our u and dv, right? So we're going to use here, since algebraic is first to be considered than our exponential form, so let u be equal to t cubed. Therefore, your du is actually identified as 3t squared dt. Okay? So, as mentioned earlier, we will be probably doing this multiple number of times. Let's also use here subs 1. Okay? As for the remaining, since you use here, when you have the integral of u dv is actually equivalent to the integral, is equivalent to uv minus the integral of v du. So we need to get, since we used u for t cubed, the remaining expressions e to the power of negative st and dt together with the integral form is our dv. So we'll have here, so our dv sub 1 would be equivalent to e to the power of negative st dt. By integrating both sides, okay, e to the power of negative st dt. So your v sub 1 will be equivalent to this, but of course, we will have here e to the u du, e to the u du, but your du u here in this form is actually negative st. What we need here is actually e to the power of negative st times negative s dt. So you're going to take it out here or neutralize. Hence, your v sub 1 is negative 1 over s e to the power of negative st plus c. But since we're doing integration by parts, we'll have that as it is. So you will have here your u, v needed for this form. So you have here t cubed, that's u sub 1, right? Then times your v, which is negative 1 over s e to the power of negative st. Integral of that from 0 to infinity because that's already integrated. Then minus the integral of your v, negative 1 over s e to the power of negative st, and du is actually times 3 t squared dt. Okay? So when you take this first, this one here, of course, when you take the value of t being infinity, notice here that the exponent for this will become infinity, and basically that as it approaches infinity will get the value of 0, and then minus, as for our 0, of course this is also 0 and everything would be 0 as well. That's for the first. And for this next group, let me take out this 1 over negative 1 over s and 3 as we consider them as constants. So you have here plus 3 over s. Take note, what remains here is again 0 to infinity here as well. You have e to the power of negative st t squared dt. Okay? So notice that this is actually equivalent to our previous form, which is actually for our quadratic formula, our quadratic form. Okay? So allow me to continue. Nevertheless, you already have the equivalent for that in the previous video, but allow me to continue doing this. Of course, it's equivalent to 3 over s in the integral from 0 to infinity, okay, of e to the power of negative st t t squared dt. This time, we will have this as again as our another integration by parts. So let's use u sub 2. Again, the algebraic form is considered first. So your du sub 2 is actually 2t dt. And then for your dv sub 2, that's the same thing as earlier, e to the power of negative st dt. So the integral of both sides, integral of this as well, is actually v sub 2, but we need here another, okay, negative s dt to integrate that, and of course again negative 1 over s here. So basically you will have your v sub 2 as negative 1 over s e to the power of negative st as well. So for this, take note, you have a factor of 3 over s for whatever would be the result here. So your u t squared and your v, negative 1 over s e to the power of negative st, again 0 to infinity, minus your integral of your v, negative 1 over s e to the power of negative st, and du, this is our du, 2t dt. Okay. Now, similar to what happened earlier, again, a factor of 3 over s is still here, so please take note of that. This would still be equivalent to 0 as our t approaches infinity with the same concern. And similarly, as it approaches 0, this will also be 0 and all throughout 0 as well. So you will have here 0 plus 0. And this here, again, take that out, take 2 out. So you will have here plus 2 over s and the integral from 0 to infinity here of e to the power of negative st, and then you have t dt. This is similar now to your linear. Again, we also have the form for linear, but allow me to continue so that we can actually complete this. So again, we have now two factors. Take note of this. You have first, I'm gonna use the same color, 3s here, times another factor of 2 over s, times the integral of this again. So what we will be using here is again another integration by parts. So let our u be just equal to t. So du is dt. So that's sub 3, the third form. So we'll have here dv sub 3 is of course e to the power of negative st dt by integration by parts, integral of both sides. So dt, again we need the s and a negative 1 over s here, e to the power of negative st and negative s dt. In short, your v sub 3 is negative 1 over s e to the power of negative st. So similar here, our u is actually t, and your v is negative 1 over s e to the power of negative st, and then minus, again this starts from 0 to infinity, and then the integral of v du, negative 1 over s e to the power of negative st, and at this time you already have dt. So that's the end of our integration by parts. You still have a factor of 3 over s. Another factor here is your 2 over s. Again, as this approaches infinity, that's 0. Okay? So 0. As this approaches to 0, so 0 as well. By the way, what makes again it with approaching infinity is 0 is this here. E to the power of negative infinity is actually 0. So plus 0. This time, you can now factor this one here. So plus 1 over s. Okay? So you have 1 over s. Then you have the integral of from 0 to infinity of your e to the power of negative st dt. Okay? So what we need here, just like this one, is another negative s. So finally, you will have 3 over s, a factor of 2 over s. This is 0, 0, so a factor again of 1 over s. So we also need here times negative 1 over s, as you need e to the power of negative s here, dt. Okay? So to finish this, red, blue. So the integral of this is simply this one here. So what will happen now for the final form is, not yet the final form, 3 over s, 2 over s, This one here is negative 1. Negative 1 over s squared of e to the power of negative st, 0 to infinity. So you have here red and blue. So what happens here is finally, so you will have here a factor of 3 over s. So you have here 2 over s. As this approaches infinity, as mentioned, that's again 0. So times 0. As for 0, okay, so here 0. As for substituting 0, we will just substitute that here. We don't have t in this case. So once e to the power of 0 is just 1, so you have here minus negative 1 over s squared. Pardon for a very long process, which would give us this final form. 3s times 2 over s times positive 1 over s squared. So what is the Laplace transform of t to the power of 3? This actually 6 over s to the power of 4. This is the rule for t to the power of 3. It's actually a 6 over s to the power of 4. If we're going to have some examples later on which would involve t cubed, simply use 6 over s to the power of 4 as your rule for your cube. In the next video, we're also going to talk about the rule for our t to the power of 4. But in that video, so we will not be wasting a lot of time, as soon as we see something like this, we will just substitute the rule for t cubed. But basically, if you're going to do the same process or the actual process with this, you'll be having, for this one, 3 portions of integration by parts. So for t to the power of 4, probably you will be having 4 versions of that. Thank you very much for watching.